First start with what guys here? Start with the numpy. So here a numpy module, okay, mainly we use to create arrays, to create what, to create arrays guys, to create arrays, all of you. So and it is used mainly to analyze a huge amount of numerical data, huge amount of numerical data, all of you. Which data? Numerical data guys. This is about numerical data, it's about tabular data, it's about analyzing the data, all of you, right? Numerical data, tabular data, and then finally analyzing the data by creating the graphs. So numpy module we have to import. First of all, we have to install and import. How to install the numpy module? All of you, how to install the numpy module? Now I'm not going to give theory part guys here. I'll share you the document later if you want the theory point, all the points. Okay, these are all the points. I'll share you the document later. Just directly I go with what here, the basics and create the graphs, the programs. Okay. So first what we do, we have to install the numpy module. How to install means go to the command prompt here, command prompt pip install numpy or numpy, pip install numpy or numpy, right? So if I click enter, then it installs. But whenever we use pip, then we have to check it compulsorily. Internet is mandatory guys. Okay, it is mandatory, it is mandatory. If it is not there, then it will not install. It says that retrying error. It says what? Retrying error, retrying error. Okay, that's one thing. And actually in my laptop I think already numpy module is there. That's why it's saying that already requirement satisfied. In my laptop already previously I used numpy for other batches. That's why it's saying what here, required requirement already satisfied, okay. That means already it's available now. Now I'm going to use which platform we use to make the programs. Let's take Jupyter notebook guys. I'm going to use a Jupyter notebook, okay. Jupyter notebook we try now. So that also we have to install guys. This also we have to install. How to install means again pip install Jupyter pip install. See, all saying requirement satisfied, right? That means what, in my machine already it is available. If it is not available, it installs properly, no problem. If it is there, means installing over. Next we have to open again. How to open this one? Simply we use a Jupyter notebook. Jupyter notebook. Just we type what here? Jupyter notebook. Click enter. It opens now. It opens. Right. That's fine. Now Jupyter opened guys. Jupyter opened. Now I create the one file. Create the one file here. We have to create our file for our programs purpose. Take the Python. All of you observe here. I go to the new and click on the Python 3. A new file opened. In this new file, and we can start this programs. And our file name is untitled, right? Now give some name. I am giving suppose data analysis. Okay, data analysis. Just I'm going to rename. That's all of you, right? Then now what we do here, first I'm going to import what, import numpy guys, all of you. Import numpy, right? Now what we do, we create arrays, right? By using numpy, what we do, we create arrays. Arrays are different types. Like zero dimensional array, 0D, zero dimensional array is one thing. Next 1D, one dimensional array, 2D, two dimensional array, then 3D, three dimensional array, three dimensional array. Like that, there are different types of arrays are there. Different types of arrays are there. One dimensional, two dimensional, three dimensional arrays. Okay. Right. Let us see now how to create first a 0D, zero dimensional array. Zero dimensional means so for numpy I am giving the some alias name as np. Np is the alias name of what numpy, right? Numpy. Now np dot which function we use? Array function we use. Which function? Array function we use here. Array of I give just one value. Any one value, any one value. I give any one value. I'll take for example a1. A1 is the array name. A1 is the array name. Then print of a1. Print of a1. So now writing the program over, then we have to execute. We have to run the file. One option is there above. Run. Run is there. The second one is just a shift to enter. Shift to enter. If you click normal enter, it goes for new line. It goes for new line. If you want to execute, shift enter. Shift enter. Yes, print a1. A1 value printed. This is what here zero dimensional array. If you want to know is it zero dimension or one dimension or two dimension, three dimension, then print of a1 dot ndim. A1 dot ndim means number of dimension number of dimension number. Which one here? Zero. This is the zero means array with one value. One value is what here? Zero dimensional. Zero dimension. All of you, right? And actually, what is an array? Array is a collection of homogeneous elements. All of you, just what is array? Array is a collection of what here? Collection of homogeneous elements. Homogeneous elements. What is the meaning of homogeneous? Homogeneous means same type of elements like all integer numbers or all float values. A array with all float values, all bool values, all string values, all int values. All elements must be same type of elements. That is called what? Homogeneous elements. Okay, homogeneous elements. Generally, if you see a list in Python list, it can be homogeneous or it can be heterogeneous also, right? A Python list, Python list can be homogeneous or heterogeneous. But numpy array is only which one? Is only collection of what? Collection of homogeneous elements. Collection of homogeneous elements only. But Python list is what here? Collection of either homogeneous elements or heterogeneous elements also. Heterogeneous means what? Different types of values. A set of values, those combination of integer values, float values, bool values, or string values, all combination possible. But homogeneous means only same type of elements only. Okay, right. So this is what guys here. This is what zero dimension. This is what here zero dimension array. Zero dimension array. Now let us try one dimension array guys. Now one dimension array. So 1D array. 1D array. Here also first what we do, import numpy as np dot array of which function we use? The array function we use. Array of, then if you take the only one value, that is called zero dimension. All of, if you take only one value, that is what? Zero dimension. Now if you take the collection of values within the square brackets, collection of values, that is called what? One dimension. So this is the one zero dimension, this is the another zero dimension, one more zero dimension, one more zero. Collection of zero dimensions is called one dimension guys. See, zero dimension means what? One value. Means what here? One value. So here collection of one values, right? Collection of one values means a collection of zero dimensions. This is what we can say. We can say that here collection of zero dimensions is called what here? 1D array. Now let's take here suppose A1, then print of A1. Now run this one, you can see the result came here. The result came. The same if you want to know the dimension, print of A1 dot what here? Ndim. A1 dot ndim. You can see it is the one dimension array. One dimension array. Okay, right. Next one, let's go with the 2D guys, all of you. Two dimension array, two-dimension array. Here also again what we do, import numpy as np dot array of. Now all of observe logically. So see, if one value is there, that is called a zero dimension. If collection of one values means collection of zero dimensions is called what? One dimension. Now collection of one dimensions is called two dimension guys. Collection of one dimensions. Collection of one dimensions is called two dimension. Let's take this one. All of observe here. I will take a one dimension here, one more dimension here, one more dimension like this. And here I will take for example 1, 2, 3, 4. I will take here some different values like this. All of you, and I will take different values, something like this guys. All of you. Now this is the what here? One dimension. This is also one dimension. This is also one dimension. Collection of these all one dimensions is called what here? Two dimension. So I can say here. This is called what? Collection of what? What collections of one dimensions is called what? Two dimensional array. Then I give the name. Here again. Some A2. A2, right? Okay. Then print of A2, yes. Sorry, here, right? In each one, how many are there? Four, four, four. All of okay. Then fine. Now you can see now all of you can observe here. First 1D, second 1D, and then third 1D. Right? All of you. This is what now 2Ds, right? Then I can take print of A2 dot ndim. A2 dot ndim. You can see now two dimensions. Two dimensions. Now the last one is there. What's the last one, all of you? That is the 3D array. 3D array. You can tell me now here import what? Import numpy as np dot array of. Now you can define the 3D. What is 3D? Define now. All of you guys, what is 3D? I given the definition of this all right. Okay, 0D means one value. 1D means collection of 0Ds, and then 2D means collection of 1Ds, Now what is 3D now? What is 3D? What is 3D? Guys, do you reply all of you? All of you guys reply. What is 3D? What is 3D? What is 3D guys? Tell me now. All of you guys, give reply please. Everybody please give reply. What is 3D? What is 3D? All of you. No reply coming here. What happened? No reply. Yes, Sindhu. Collection of 2Ds, right? Okay, very good. All of you guys will play. Collection of 2Ds, okay. That means what here? That means what here? I will take what here? Observe all of you. Observe here. So first one 2D, again second 2D, then third 2D. In each 2D, in each again 1D, second 1D, third 1D. Here also 1D, second 1D, third 1D. Allow here also first 1D, second 1D, third 1D. In each 1D, 0D, 0D, 0D. Allow, right? Again 10D, 0D, 0D. Like this. I'll take the different values, all of you. I think you are clear this one, right? Okay. The last one, like this. Now let's take something A3 equal to A3 equal to. This is the one 2D, right? This is the second 2D. This is the third 2D, right? Okay. In the first 2D, again one 1D, second 1D, third 1D. It again first 1D, 0D, 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 like this. All of each one same. Each one same here. Then let's go with print of A3. Print of A3 somewhere some maybe spelling array spelling, okay, right? You can see all of them. This is the one 2D, second 2D, third 2D. All of you, right? The collection of this first 2D, second 2D, third 2D, okay, third 2D, and each 2D, what is again first 1D, second 1D, third 1D. In each 1D, 0D, 0D, 0D. Again, 0 means one element, boy, a single element. And if you want to know that dimension, A3 dot what now? N dim. A3 dot 1 dim. You can see now, this is what 3D. 3D like this. So 0D, 0 dimension, 1 dimension, and 2 dimension guys, okay, and 3 dimension finally. These are the types of what here? Types of arrays, right? Arrays. Now, all of what we do, we can perform the arithmetic operations, we can perform iterations, all of you. On the same arrays, we can perform different operations. Arithmetic operations possible, iterations possible, finding the aggregate operations possible. These are all operations we do, guys. Okay, means how to perform the first arithmetic operations. Okay, which one? Arithmetic operations. Arithmetic operations we'll see now. Arithmetic operations we'll see now. Like which one? First one, let's take the add, guys. Performing the addition. We'll take addition, subtraction, multiplication, division. Okay. This we try now. First, what we do? We perform the addition. We perform the addition of two arrays, guys. Addition of two arrays. And then next we perform what here? We perform the subtraction also. All of subtraction. Third one is multiplication. The fourth one is you can perform the division also, guys. First we see these operations. All of you. Addition, subtraction, multiplication, division. Okay, right. So for this all, first let's take the just attack two arrays now. Import numpy as what? As np. Import numpy as what? As np. Now np data, I'll take the first array. Let's take suppose one dimensional. Suppose like this, all of you. I'll take as a a1. I'll take as a a1 equal to. I'll take one more array also. Np dot array. array of array of let's take like this. Now a1 a2 a1 a2 a1 is the one array, a2 is the another array, a2 is the another array. Now generally what can we do? A1 plus a2, right? Generally can perform a1 plus a2, a1 plus a2, that is what here a, that is what here a generally, right? Then print of what? Print of a, print of a, all of you can see now. So 2 plus 4, 2 plus 4, 3 plus 3, 4 plus 5, 5 plus 6, right? All of you. Means here the elements are adding, guys. First 2, 2 plus 4 how much? 6, 3 plus 3, 6, 4 plus 5, 9, 5 plus 6, 11, right? So here directly what is happening? Elements adding here, directly elements adding, but the same thing are not possible directly in the Python list, guys. All of you. In Python list, suppose imagine now lst1 2 3 4 5, lst2 4 3 5 6, now lst1 plus lst2, is it possible, guys? Tell me output like this, all of you. In Python, is it possible now? In Python, suppose I'll take as a, this is the list one. Just imagine, guys, just imagine now, this is the list one, okay. I will take here, this is the list 2, then list 1 plus list 2 assign to list, then what is the list, guys? Let me know what is the list now. What is the list? All of you guys, can you reply now? All of you guys reply. We all know Python very well. We all know Python very well. So here directly elements adding 4 6 6 9 11 coming. Here what is the output now? In case of Python, what is the output? Tell me now. In case of Python, what is the result, guys? All of you guys reply. All of you guys. What is the answer now? Right. The output will be a list of 2 3 4 5 4 3 5 6. All elements will come. Means here the plus applying between two list objects, between one list object. But here the plus applying between the elements, the plus adding, the plus applying between the elements. That is the difference between here the arrays and the list objects, guys. One of the difference. Okay, right. So if you want, you can see now, right? Okay, first list, then second list, right? To get like this, we should perform some other operations. Okay, right. But right now, just you forget about this one. So now here I am using what now? I am using only the plus operation. Using what here? Plus operator, guys. But the numpy supports one function, that is add function. That is what? Add. np dot add of a1 comma a2, let's take the a again, then print of a, yes. All of you observe. So for addition operation, generally we use plus, but the NumPy model supports what? Supports add also. It supports add. Okay. All of this is what? Performing the addition operation, right? Performing the addition operation. Performing what here? Performing addition. Next, let us try take the same arrays now. We'll take the same arrays, guys, next. But now perform the subtraction. Right. Now to perform subtraction, we use a1 minus a2. a1 minus a2, then we use a equal to, okay, a equal to, then print of print of a, yes. Now I'll observe here. So in which operator we use a operator we are using, sorry, minus operator we are using, right? So that means 2 minus 4, how much here? Minus 2, 3 minus 3, 0, 4 minus 5, minus 1, 5 minus 6, minus 1. That is by using symbol of subtraction, right? But it supports on the method also, guys. It supports on the method also. That is np dot subtract, okay, subtract of a1 comma a2 assigned again a, then again print of a, you can see now, okay. This is what now performing which operation here, subtraction, right? Okay, performing subtraction operation, right? And then on the same two list objects will perform the multiplication also. We will perform the multiplication also, guys, on the same right, both are same. A1 into, okay, a2 assigned to what here? Assigned to a, assigned to a, then print of a, you can see here. So 2 into 4 8, 3 into 3 9, 4 into 5 20, 5 into 6 30. The same case again we have np dot what, np dot multiply of a1 comma a2 assigned to a, then let's take print a, you can see, all of you same, right? Same operation, guys, same operation, all of you, right? And then let's see one more also, the last one. Let's try to perform the division operation, guys. Which operation? Division operation. A1 by a2 assigned to a, print of a, you can see in all of you. So first 2 by 4, that is 0 0.5, 3 by 3 is the 1, and 4 by 5 0 0.8, 5 by 6 0.83. And all of you can observe, actually this is the float, right? This is the float, right? Okay, but 3 by 3 means what? 1, actually 1, right? It must be 1, but now 1 dot came. Why 1 dot came? Actually this is the 0.5 float value. It's also float value, it must be integer, actually it must be integer, right? 3 by 3 1. But here array means what? Collection of same type of elements. That's also, it also became what? A float type. Array means what? Collection of same type. Already all are which type is there? Float type is there, right? Float type is there. That's why it also became what now? Float format, right? So these are the which one, guys? These are the arithmetic operators. All of you performing multiplication, and here performing what? Performing division, right? Okay, now let us see how to do indexing, guys. Indexing, slicing, okay. In Python we do indexing, slicing, and iteration, right? The same thing you can do here also, guys. Same thing we can do here also. Indexing, slicing, those all operations, so we'll do here also, guys. So we'll see now how to make the indexing. All of you. The same way, these all operations we can do on 2D also and 3D also, guys. The same one we can do these operations on 2D, 3D also. Okay. Now, so types we have created, an arithmetic operation solver,